Getting started with chaos engineering, design of an implementation framework in practice. This is an industry track paper based on a master's thesis project in industry conducted by Hugo Jernberg and supported by myself, Per Runesson, and my colleague Emily Engström at Lund University. The industry context of this project is ICA-gruppen. ICA-gruppen is a grocery retail in Sweden, and they also have business in the Baltic countries. In addition to the grocery retail business, they have a real estate firm, primarily for the stores, and a chain of pharmacies and a bank. The turnover of the whole business is 120 billion Swedish krona. In ICA-gruppen, they have private stores combined with central scaling opportunities. So they centrally support financing, they support concept development for the ICA concept, and they support the digitalization for the different stores. The problem addressed in this context is based on that the IT systems are developed and operated by ICA centrally. They are offered as a service for the retailers and can be tailored for local needs. They cover web presence and advertising for the local stores, and they also offer e-commerce services. The IT department is distributed over several segments of the corporation, and they have hundreds of employees. These systems are business critical both for ICA and for the retailers. The design problem we addressed in this project is about introduction of chaos engineering to ICA-gruppen. And the question is how to validate and improve the resilience of large-scale business-critical software systems with chaos engineering. The project was initialized and carried out in the centralized IT department of ICA, but it was intended as a lighthouse project, meaning that they want to spread it out over the different parts of IT services across the organization. So what is chaos engineering? It's defined as the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So the idea is to test whether a system's resilience is sufficient to meet the real-world needs. This is a set of techniques developed or originally developed by Netflix, and they have spread over different kinds of businesses. The basic principles of chaos engineering or chaos experiments can be captured in 4 steps. First, define the normal behavior of the system under test, so the steady state which we want to keep. Then define an experiment which is aimed to stress this system in one way or another. Running this experiment means simulating real-world events which disturb the steady state of the system. And analyzing the outcome, we can prove or disprove the hypothesis that the system withstands the stress. The overall goal of the project was to assess the possibility to introduce chaos engineering into ICA-gruppen. The primary result is this chaos engineering framework, which is a description of how to introduce chaos engineering in an organization. The framework consists of 4 recommended activities, each split into several steps. Support documents guide and support the activities, and the outputs are the results of the steps. The discovery activity defines the system and the test, which type of system according to a taxonomy of a framework, which tools are useful, and which experiments to run. For experiments that we hypothesize will be handled well by the system, remember, we are experimenting with operational systems. These experiments we add to the backlog. Otherwise, they create improvement opportunities, either to improve the monitoring of the system or to improve the resilience mechanism of the system itself. Next, we implement one chaos experiment with consideration on defining monitoring metrics, which tools to use, configure, run, and evaluate. The implementation phase can keep going, while from an organizational point of view, chaos engineering can be advanced by entering the sophistication phase. This involves an analysis of how mature the organization is in their application of chaos engineering. This assessment results in a sophistication map, telling the maturity of the organization. Last, based on this map, strategic decisions can be made where to expand the experimentation, based on the importance and state of practice. This may involve extended use of features in existing tools or introduction of new tools, and then we loop back to the implementation phase again. This framework was derived in a design science framework. First, the problem conceptualization included literature study and interviews with people in the organization. We found 6 peer reviews and 6 gray papers presenting important material on chaos engineering. And we conducted 6 interviews with people in the IT organization and people knowledgeable about different kinds of incidents that could take place in the system. Then, based on the information we got from the literature and from interviews, we defined the framework as I just presented. Based on 6 other interviews, we identified the areas of work, and based on an assessment of different chaos engineering tools, 27 tools that we found openly available, we set up the framework and its corresponding activity descriptions and output documents. And finally, we validated the framework by applying it to 2 different teams and systems. However, as it was only an initial phase, we only evaluated the discovery and the first part of the implementation phase. So, in summary, the outcome of this work is that we recommend companies using this framework as a guide for their implementation of chaos engineering. It's well rooted in real-world problems. It's based on what is published in the literature, both peer reviews and industry reports, and it's based on existing open source tools which are available. And finally, the systems are still working since I am one of the many customers of the ICA Gruppen retail companies. Thank you very much.